CHS. Here we're going to do another lesson over logarithms. So this whole chapter first talked about exponential equations, did some stuff with that. Then last week I introduced a logarithm to you, and we just did basics. We just talked about how you can take it from logarithmic form to exponential form, and also evaluation. So those are the basics of logs. So what we're doing today is we're actually going to solve equations that have a logarithm in it. And so we needed to do those basics so you can apply it to this. So we're going to talk about one way to solve a logarithmic equation. So just a quick review. What we're going to end up using in this process are two things. The rewriting process that we used last time, where we take something from logarithmic equation to exponential equation and then solving using our exponent key, okay? So this first little review, so notice here, there's three places you can put numbers in and around logs. You have the little base, you have what you're taking the log of, and you have what it equals. So our equations today is, instead of knowing like this or this, what we're going to do is have some sort of x or some sort of variable expression in there. But regardless of what is in those three spots, you can always rewrite. So use that walk around method that I talked about last week. So we do the walk around here. We start with the little base, it's 9. We walk around to the 2, so the 9 becomes our big base. 2 becomes the exponent on 9, and then it equals 81. And so that was how we had to use it for just the rewrite part. But I said today our equations, instead of having an 81 here, we're going to have some sort of variable of x. So we can still do that walk around method. We just, instead of having 9 squared equals 81, which we know, it'll be 9 squared equals like x plus 2 or x minus 5. So then what we'll have to do is actually solve out the exponent and then solve for x. So let's look at a few examples. So we're just going to talk about one way to solve logarithms. So you're going to rewrite to help you solve. So there's a couple other methods. We're just going to talk about one of them. So we're going to use that rewriting that we talked about last week to help us solve a logarithm now. It's not required to have parentheses around here. A lot of times there is, but again, if you notice with this, we still have our logarithm. It's the log base 8, but instead of having a number here, it's now an expression. So it's log base 8 of x plus 2 equals 3. So the way we have to solve this is, what I like to say is x is trapped with the log. So the only way to untrap it is by rewriting it, okay? So this is in logarithmic form, so we're going to rewrite it into exponential form and then solve for x. So just like before, you know now there's not a number there, there's an expression. We can take the 8, make it our big 8, walk around to the 3, 3 becomes its exponent, and then it equals the x plus 2. So now we've untrapped the x and we've created an equation we can actually solve. Because here we can't solve anything like that because x is trapped with the log. But now that x is released from log and now it's set up as an exponential equation, you can actually figure out what 8 to the third is, and then you can just have to subtract 2 to solve for x. So remember, you can do exponents in your calculator. So 8 to the exponent of 3 is 512. And then to finish solving for x, just like we've done in very many years past, subtract the 2. So x is going to equal 510. So we're going to talk about a couple other little things that you can see with this, but that is the basics. So we're going to use our rewriting process that we learned last week with logarithms, and now apply it to being able to solve logs this way. So let's do that one. So same idea, we have log, little base of 2, and then we have 3x minus 2 equals 4. So again, the x is trapped with the log, so the only way we can solve for it is to rewrite it into its exponential form to untrap the x, and then you can solve for it. So again, we start with a little base of 2, walk around to the 4, so it becomes 2, big 2, 4 is your exponent, and then it equals that 3x minus 2. And again, it creates a little equation for us to solve. First thing, always, you have to solve out the exponent. That's good order of operations. So you have 2 to the 4th, that's 16. Once you do the walk around, solve out the exponent first, and then it's just a regular equation that you've solved since we've introduced algebra to you. So we're going to add the 2. Yeah, 18 equals 3x, 5 by 3, so x equals 6. You can get all kinds of answers. Your answers actually could be negative, positive. So far I've done nice whole numbers for you. You can do fractions, decimals, so you can get all types of answers for x. But again, the process is rewrite, solve out the exponent, and then keep solving for x. So I actually have 2 other little ones to do with you because there's 2 other variations, but again, that's the main process. Rewrite, solve out the exponent, and then get x by itself. So the difference with this example, if you notice next to log, usually we have a little number next to g, and so we talked about that a little bit last time. There is a common log that we use, and it's actually the one that's programmed into your calculator. When there's no base next to log, it is base 10. So I know that it gets a little bit tricky in math because for the most part, up to this point, when we haven't seen anything as a 1, but there's a couple times where it's more than just 1. So here, if you don't see a little base next to log, it is a 10. So you can still do the rewrite the same way. So we start with that blank space. I went ahead and wrote in the 10 so you can see it. So 10 becomes the big 10, walk around, 2 becomes its exponent, and then it equals x minus 4. So we walked around. Next thing is solve out the exponent. So we have 100, and that equals x minus 4. So then solve for x, add the 4, so you get 104 equals x. So there's that little variation. But again, ultimately same process, rewrite, solve out the exponent, then you get x by itself. So there's one other little one, and then that'll be it for this lesson. A couple things with this one. Like I said, the parentheses aren't necessarily required, so this one I didn't put parentheses around that. And also, if you notice, my x is squared. We've talked about those types of equations before, so all types of equations that we've talked about can always pop up no matter what type of equation that we're solving. So let's work on this one. So again, the x is trapped inside the log, even though it's x squared. We can do anything we really want to x. We just have to get it by itself eventually. So the first part of the process, rewrite. So you start with the 5, walk around to the 3, that becomes its exponent, so it's going to be 5 to the 3rd power, and that equals x squared. So once you rewrite it, the first thing you need to do is still solve out the exponent. So 5 to the 3rd power is 125. That equals x squared. And then hopefully you remember the way to get rid of a square is by using a square root. So we talked about that when we did our whole quadratics stuff all the way back in chapter 4. So we're going to take the square root. I do like you to go ahead and square root out. When we did that, we do 2 decimal places. And then the other thing I always try to remind you of, whenever you're using the square root to solve for x, remember there's 2 answers. It's both positive and negative, that square root. So the square root of 125 is 11.18. So it's both positive 11.18 and negative 11.18. So instead of writing just 11.18, we always remember to write our plus or minus in there to show that it's both of those answers. Now, back when we did that, I always said the phrase, it's always plus and minus, I when it's negative. You really shouldn't have to worry about the i's with this one. Every once in a while you might see that, but for the most part it's just square rooting positives. So when you square root a positive, always plus and minus. If you do end up having to have to square root a negative just like before, it does create an imaginary solution. So there's our answer to that. So once you kind of understand the basics of logarithms, solving them actually works pretty much the same type of thing that you do with those, only that instead of having all the numbers, you now have an x. So I hope this all made sense. So if you feel free to pause, rewatch. I'll post the notes as well. But again, hopefully it made sense. If you have any questions, you can email me. I'll set up a video conference. So thanks for watching. Bye.